Hi, everybody. Mrs. White here. I just wanted to take a minute to give you a little preview of today's assignment, where you'll be asked to locate certain angles on the unit circle that are either measured in degrees on the first page, or if you look at the second page, you'll be asked to think about the location of angles in radians. And you'll notice that I have one problem on each page already done for you so that you have an example to follow when you try the others. But I'd like to talk you through these so that you have a sense of how you might approach locating angles on the unit circle. And this is going to help us get ready to actually build the unit circle next class. So some important thinking here today just to get your brain ready to move forward. So if you look at this document right here, you're going to be trying to locate in this first problem where 120 degrees is on the unit circle. And so first we need to think about how 0 is defined as our starting point over here on the positive x-axis. And then as we move counterclockwise, the angles get bigger. We know that a full circle is 360, which means halfway around the circle must be 180 degrees. And I can even cut that in half and see that up at the top, a quarter of the way around the circle is therefore 90. So now if I look more closely at my angle here, I can see that 120 degrees is bigger than 90, but smaller than 180. So I know I've gone past 90, but not all the way to 180, meaning this angle must be somewhere in quadrant 2. And before we can figure out exactly where, let's take a look at how this circle is being broken up right now. So I'm going to have you look over here at these angles that I've labeled in quadrant 1. Okay, if I look closely here, I know that 90 degrees is a quarter of the way around the circle, meaning 90 degrees is here up top. So if I picture cutting that in half into 2 equal slices, then halfway through quadrant 1 must be 45 degrees. So these middle markings here this right here would be 45 degrees. And I'm going to introduce you to this idea now of something called a reference angle. A reference angle is always the angle made with the x-axis. So in quadrant 1, I'm 45 degrees past 0, putting me at 45. But over here in quadrant 2, this middle line would be 45 degrees short of 180. So I could actually do 180 minus 45 and get 135 right here. I could move 45 degrees past 180 to get this angle measure in quadrant 3. And in quadrant 4, I could move 45 degrees backward from 360 to land at 315. So I'd like you guys to start training your brains to always move up and down from the x-axis by adding and subtracting. You're moving this reference angle amount either bigger or smaller than the x-axis. And I think you'll find as we move into the unit circle next week that moving forward and backward from the x-axis, thinking about this reference angle will be a key concept. Okay, so let's get back to our 120 degrees. You could think about how 120 degrees is 30 bigger than 90. And by the way, I should probably look back over here. These 2 other markings that surround the 45 are actually reference angles of 30 and 60. And I can see that because 90 is the full first quadrant, and these 2 smaller lines are that first quadrant being cut into thirds. So 90 divided by 3 is 30, and then I can count 30, 60, 90 as I hop my way around. So all these taller and shorter markings are some unit of 30 or 60 away from the x-axis. So I could get to 120 by saying it's 90 plus 30, and that would put me right where this star is. But what I'd like you to start trying to do is think about how far am I away from the closest x-axis. So if I think about how this is 180 and I compare 180 and 120, I can see that those are 60 degrees apart, meaning that 120 is 60 degrees away from that 180 on the x-axis. So now if I take my 180 and I move 60 degrees backward, which is the tallest of the 3 lines, kind of like I see that 60 over here, 180 minus 60 puts me right at that same location, 120. Okay, so with degrees, you're either moving backward from 180, forward from 180, forward from 0, backward from 360, and you can get yourself to that correct angle there. As you guys scroll through this page, you'll see that there's 3 more problems for you to try. And as you do these, please try to follow the instructions where not only you're labeling where the angle ends up, but maybe using some arrows to show how you got there, maybe using some markings to indicate the size of the reference angle, and ultimately mentioning what quadrant you're in and why. Okay, so a few more for you to try here. I'm going to scroll ahead to the second page. You'll notice I did number 6 as an example. So radians are brand new at this point. So let's take a little more of a detailed look at how radians work. And I'm going to actually pick number 6 because it's even one step harder than number 5 would be. So here we go. We have 5 pi over 4 radians. So one option would be to use dimensional analysis. Those of you that are in chemistry, the video you just watched should have felt a little familiar with canceling of units. This is really dimensional analysis. So we've seen that 1 radian is the distance that 1 radius would wrap around the circle. And we ultimately saw that if I go halfway around the circle, that's the same thing as pi radians. So 180 in degrees is the same thing as pi if we're measuring in radians. So one way to approach this problem is to take your starting angle, 5 pi over 4 radians, and multiply by this scale factor here that says that there are 180 degrees for every pi radians. And now if I look closely here, I've got radians on top and I've also got radians on the bottom. The units radians cancel out. I also see a pi on the top and now I have a pi on the bottom, so that pi cancels out too. And all I'm left with on the top as I multiply across is 5 times 180, and on the bottom as I multiply across, I'm just left with a 4. And the only units left here is degrees, so I'm now going to be in degrees when I finish this problem. And now I can pick up my calculator, multiply 5 times 180, I get 900, divide that by 4, and I now know this is 225 degrees. Okay, another way to think about 5 pi over 4 radians, and this might be sort of a shortcut here, is to really just think about how pi in radians is 180 in degrees. So why not just take that pi out of the problem and replace it with 180 degrees? And now what used to be in radians is now in degrees. Okay, I could do the math the same as in the previous example where I do 5 times 180 and then divide by 4. But let's think about this a little differently. I'm going to go back to this highlighted part here. Pi over 4 really just means I have a half circle, which is pi, cut into 4 equal parts. Or in other words, 180 degrees cut into 4 equal parts. And if I cut 180 into 4 equal parts, I get 45. And now that 5 just tells me, now do that 5 times. So if I do 5 times 45, I land on that same 225 that I got using the dimensional analysis method over here. So some way we want to think about how 5 pi over 4 radians is really equivalent to 225 degrees. From here, we can really approach this just like in the last problem now and think about how 180 degrees is halfway around the circle. 90 more than that would put me at 270 down here at the bottom. 225 is between 180 and 270, and specifically it's exactly 45 degrees bigger than 180. So if I take my 180, add 45, that puts me right at this middle location here in quadrant 3 where I see the star. But let's take a look at this even more closely, and this might ultimately be your biggest shortcut at all. Notice these markings that I wrote off to the side here. Okay, so if I think about how 45 degrees is really pi over 4, and I can think of that because pi is 180 cut into 4 equal parts would give me 45. So whenever I see a 4 in the denominator like I see in this problem, that's really 180 cut into 4 equal parts, which means I'm dealing with a 45 degree reference angle. So I already know I'm going to be at one of the middle slots in one of these 4 quadrants here. And now I can do even better than that. If I think about how halfway around the circle is pi, why not write that using a denominator of 4? So instead of writing pi, I'm going to think of it as 4 pi over 4, because 4 pi over 4, the 4's would cancel, and that really is pi. Well, 4 pi over 4 is halfway around the circle. 5 pi over 4 is even bigger than that, so that means I need to go farther than 4 pi over 4. Specifically, I have to go 1 pi over 4 bigger. So there's my reference angle. I'm starting at 4 pi over 4 and I'm going 1 pi over 4 bigger, which lands me on 5 pi over 4. Another way, without ever even using degrees in the first place, to think about how 5 pi over 4 must be halfway through quadrant 3 as I rotate around the unit circle. I'm hoping this helps you get started. There's a few more problems that are in radians for you to try. You have a couple options for converting it into degrees, or if you're ready, you might try thinking about moving forward and backward and keeping the answer in radians without ever converting to degrees. When you guys turn this in, I'd like you to have some evidence for how you arrived where you arrived, either some math to show how you converted to degrees, or maybe a verbal explanation of how you thought through the process in radians. And ultimately, you should have a point plotted on the circle showing exactly where that angle is. Good luck. When we go to build the unit circle next class, you'll get some more, bigger chance to see this whole circle as a whole. But for right now, we're just trying to think about one angle at a time to get our brains ready to move to the whole unit circle. Thanks for listening.